so this was a case where we had seen that the delta H and the delta S both had a positive value. But let's take a look at what happens when now delta H and delta S are both negative. So we can think about this just by plotting it on our graph. Again, we don't have actual values, but we can think about what the sign should be. So if we talk about our 0 point where temperature is absolute 0, if we have a positive, if we have a negative delta H now, and we're at temperature equals 0, what is delta G going to be? Negative or positive? Yeah, it's going to be negative. So if we have negative delta H and we're at temperature of 0, our S term completely falls out. So we're definitely going to start with a negative delta G. As we increase the temperature higher and higher, at some point that delta S term is going to become greater than our delta H term. So at some point we're going to flip to where the reaction has now a positive delta G. So you can draw this into your graphs on your notes where we're going to start, in this case, if delta H is negative, where delta G starts negative, and then when it hits that threshold temperature, anything above that temperature is going to be positive. So if we had actual numbers, we could plug those into our graph, but we should be able to understand what the general trend is going to be, even in a hypothetical case where we're just dealing with, is it positive or is it negative? So what we see is that below this temperature, we have a spontaneous reaction, and above this temperature, we have a non-spontaneous reaction. That was flipped from the case where we had delta H and delta S both be positive.